Hello, everyone. My name is Wassim Ghadban. I'm the Global Vice President for Innovation and Digital Engineering at Kent. Today, I will share with you the benefits of implementing digital twin at the feed stage for optimized construction and predictive operations. I'm going to have to go into the map. Do you recall Friends episode when Joey and Chandler were in London for Ross' wedding, not knowing how to get their destination, and Joey lays his map on the ground and step on it. In order to know where he's going, he put himself in the map. Genius, right? These days, I'm sure that Joey and all of us are using Google to go into the map where directions are easy to find and information of your destination are populated in a digital map. Talking about popular times, current status, street view images, photos, interactions, traffics, reviews, and even historical records of your visits. Well, it's the same concept of digital twin, where all information of a city or a plant or site or asset are displayed in their context. You don't need to know how to read drawings, PNIDs, or PFDs to be able to locate and retrieve the information of an equipment or system in your plant or area. You just need to search and navigate to find all static and real-time information from different sources captured in different systems by different timelines from different stakeholders in a single platform, which is a digital replica. Finding information is key for success in our projects, right? And always we hear the same questions: where to find the information, what is the progress of the project, is it accurate, in which system, are we getting bad values, who's in charge, what if, what happened? And mainly because we have lack of integration of different systems used for engineering, construction, operation, and also lack of sharing the information, we want to implement digital twin to make sure that we address all the challenges. So at Kent, we are helping our client to address all of this. We address to help engineering companies, construction and operators to address all the challenges that I listed. Kent is a fresh, new integrated energy player who designs, builds, and maintains the asset that power the world for today and make it future ready for tomorrow. We are joining forces of different legacies: Kentech, SNC Oil and Gas, Atkins Oil and Gas and Offshore Wind, Kent's Houston Offshore Engineering. Our core services, it's advisory, digital engineering, conventional engineering, projects, completion and commissioning, operations, and maintenance. While with projects executed in more than 80 countries, our ambition is to become the global leader in integrating energy services driven by sustainability and innovation. Talking about innovation, we deliver innovative solutions for our client from digital perspective: consulting services, systems integration, EPC 4.0 solutions, digital feed, unified operations, and digital centers. In specific, in digital twin, we are pioneers in energy sector. To implement digital twin, we are helping our client to plan, design, implement, and select the best platform suitable for their operations. And we provide training and operations of their digital twin. We have a big list of projects delivered in oil and gas and energy sectors and different sectors as well. Like it covers different aspects of digital solutions. This year, we delivered the most advanced digital center in oil and gas for ADNOC, which is ADNOC IWC, the advanced version of Panorama. And currently, we are working with oil and gas operators in Saudi to implement digital twin for various phases of the project. So let's go back to the digital twin itself. So digital twin, always we hear the same question: where to start, what type of integration I need to have in place, what are the systems, who's going to manage it? So all these questions I'm going to address today in this presentation. So digital twin actually is a system of systems, right? We are not going to replace the existing system, rather than like integrating with existing systems used in each phase of the project life cycle. So first, we start by creating the class library, which is based on CFOS. We create the functionalities of digital twin that really address your needs, because we need to make sure also that it's not one solution fit all purpose. It's really customized to fit your needs. Then during feed, we start to integrate with the design tools, with the DMS tools, with the planning, with the cost estimate. And during detail engineering, it's more like we provide more details to integrate with the 3D, with the design tools. And also in the construction, we focus on integrating with the progress measurement tool to give 4D, 5D fabrications, and plus the safety and work permits. And during operations and maintenance, we move toward like more systems related to real-time data, whether like what integrate with historian, LIMS, OTS, and during operations and maintenance, it's more about maintenance and predictive analysis systems. So this picture will show us the ecosystem, the digital twin, and how we can connect through various systems through the full life cycle of an asset. So the data actually gets matured as we move toward operations. This is very important. We start engineering data increase as the feed proceed. Data are increased as engineering activities proceed. Engineering data are updated to reflect as built drawings. Then real-time operation and maintenance data are integrated in the digital twin. Engineering data are maintained as we operated. Live streaming is a layer to monitor operations data. Operation historical data will provide analysis and insight and can be used for unmanned and autonomous operations. If we take like the conventional project life cycle, right? We know the constraints of all projects: scope, cost, and time, and definitely quality. And there is a big list related to all these constraints, starting like the delay, the budget for the cost, and the agreements, the variations from the quality perspective. And if we take each milestone for the project, so starting by the feed, we know usually the company who developed the feed, they use different tools and they have different deliverables to deliver, like talking about studies, PNIDs, PFDs, layouts, as of studies, 3D model, design basis, process simulation, and engineering documents, MDR, WBS. So there are really a big list of deliverables. And usually at feed, we have always uncertainties because we don't do the detailed engineering. And there are always uncertainties there related to cost, related to scope, and related to quality. And when we move to EPC, we have noticed that all EPC contractors, when they estimate a project, they add 10 to 15% as a contingency on the capital cost on their estimate, because of these uncertainties, because of probably like to cover like what's not unknown in the project, what's still not unknown in the project, and to cover all the risks that might happen during the project. And we notice as well in the construction, I think many presentations today talk about the the losses in the construction and the claims and the delays we see to achieve the milestones. And definitely in operations, when you don't have an efficiency and integrated operation, you are losing money for your operations model. So our solution is to create digital twin as the digital feed stage. What we call digital feed stage actually is to integrate all the deliverables from 1D, 2D, 3D, 4D, 5D. So we're merging all this information and we are connecting to all systems. We are mapping all of these by tag through the class library, so we can generate like compliance sheet. We integrate as well. We do the construction sequence, the 5D, to make sure that the contractor will understand properly what the sequence of activities for construction. We as well use the VR to ensure that the design is properly fit. We check the elevations. We check all the aspects of the design. So this will help the whoever like the stakeholders that's going to manage the other life cycles, the following life cycle of the project, to understand properly the project, to understand the activities, to understand the schedule, to understand the required quality. So again, this is like a single source. This will give you a single source of truth where you have one platform where you can retrieve the information of your equipment or system or the plant, regardless the source of the information. So you can have all this information integrated in one place, and all this based on their the users based on their security and the access. They can retrieve this information and they can make sure that this information is accurate and relevant to what they're looking for. Well, by looking to this this approach, right, we have achieved big benefits for our clients. So having starting the digital twin implementation at feed will definitely shorten the project timeline, improve quality and accuracy of the design, reduce cost, control cost, and improve delivery. And there are also many benefits that's not quantified, but recognized by all stakeholders. As we said, everything related to the awareness about the scope, cost, and quality. The goal, again, to start at the feed, yes, but we should always remember that we need to cover the full life cycle, right? So starting at the feed is giving you the best value of implementation of digital twin, and that's what we see right now. Aramco, they are the first one who follow this approach. So to develop the ecosystem of the life cycle where data gets like matured as we move from operations phase to achieve like the 8 dimensions for each equipment. So 8 dimension, this is the approach that we created to make a standard approach about understanding about the information that we need to capture for the equipment, system, or plant. So during engineering, we are capturing this level of information, then the construction and operations to achieve the 8D dimension. So the summary of my presentation is very important that we remember that digital twin is a replica of asset, yes, but don't wait for the physical asset to be built to have the digital twin in place, because values cover projects and operations of assets. It's very important that to also consider the digital twin is a set of big list of solutions, and this list of solutions actually goes on and contribute in the development of smart cities and the global ecosystem, where everything is synchronized and integrated for our sustainable future. Thank you.